So hello and welcome friends to our channel Entromech, and here we discuss about basic mechanical engineering concepts. So guys, we have started our new series regarding the selection criteria of solenoid valves. So there are many parameters based on which we can select our solenoid valve. So we should know about all these parameters, how these parameters will affect our application and all those things. So today we will see the principle of operation. That means based on the principle of operation, what are the broad types of solenoid valves, what is their working principle, and all those things in detail. So without wasting time, let's get started. So the solenoid valve selection guide you could see over here, and it is very important that before choosing a valve we should know the parameters. So let's check out the principle of operation over here. Now we can see there are different types of solenoid valves having different working principle. So basically there are three types of valves which can be direct operating from 0 bar, then we have semi-direct operated, and then the indirect operated, which are also called as pilot operated, which require a pressure differential at least of 0.5 bar. So these are the broad categories of the main categories of solenoid valves, and we will see their working principles and how these valves are operated, all those things in detail, right? So it is very important to choose the right operation principle according to your operation. So let's check out the solenoid valve types over here. So we can see the solenoid valve fast facts. Some of the facts are given over here, and let's check out how does a solenoid valve work. So that is important, and what is the selection criteria we will check out. So the important thing is how does a solenoid valve work. Now you can see on the right side the construction of a solenoid valve and what are the parts of the solenoid valve. A is the armature, then B is the armature, sorry, A is the coil, then C is our shading ring, D is our spring, and then E is our ferromagnet, then F is our seal, and G is our valve body. So these are all main components of our valve. So how does the valve work is whenever the electric supply is given to the coil, the ferromagnet gets magnetized and the force is generated, and because of which the spool gets lifted up and the valve gets opened, and whenever the valve gets de-energized, again the ferromagnet loses the magnetism, the force, and that's why the spool comes and closes. So this is how the valve works, and it is based on the electrical phenomena, right? So in these valves we have different types like normally open and then normally close and all those things, right? So you can see the seal material over here, and the input and output, the inlet port and the outlet port, right? So this is the general layout of a solenoid valve, and you should know the basic principle of a solenoid valve, right? So let's see the other types. Like you can see the circuit function of solenoid valve, and then we have the solenoid valves are used wide range of application, right? You can check out the types, the normally closed solenoid valves, and you can see what is the meaning of normally closed. Now you can see on the left side the valve is closed in a closed position, that is it is normally closed, and as soon as the coil is energized, the inlet port is connected to the actuator. That means in normal condition the valve is closed, that's why it is called as normally closed. Whenever the valve is energized, then only the inlet port is connected to the actuator side. So that's why normally it is closed type, right? So this is the meaning of normally closed valve. on the contrary, the normally open valve, if you could see, it is normally open. The inlet port is connected to the actuator port, and as soon as we energize the coil, the solenoid coil, the valve gets actuated, the valve gets closed. So this is called as normally open solenoid valve. So you should know the meaning of normally open and normally closed valve, and in which type of application which valve should be used, right? So this is normally open valve, and here you can see that as soon as the valve is energized, the next position is activated. But if there is if the valve gets de-energized, the valve comes to its original position automatically. Now this is the difference between monostable and bistable solenoid valve. The bistable, or it is also called as latching solenoid valve, so it is switched by momentary power supply. It will have a permanent magnet. So what does it mean? That even if there is a cutoff of the power supply, the valve will not resume to to its default position, but it will remain in its home position. That means if we say normally open valve, the valve is normally open. When it is energized, it will get closed. So what happens if the energy is cut off? The valve again comes to the normally open position. But in case of bistable valve, the valve will remain closed. So that is the meaning of bistable valve. So this option is also available, and you will see in the upcoming section when we actually select the valve, there will be a option like a single or a latching type. So latching means a bistable solenoid valve. So you should know what is the meaning of bistable or latching type. So this is the meaning, right? Then we have solenoid valves, the direct acting, the semi-direct acting, or the indirect acting, which are servo pilot operated, and then semi-direct operating. We will see their working principles. And then we have three-way direct acting. So there are n number of different types of solenoid valves there, and what are their meanings and all those things, what are the symbols. So I will drop a link. I have done a video and in detail, so you can know about the valves, how they are denoted, what is the symbol, what is 2x2 open, what is 2x2 normally closed, what is 3x2, what is 4x2, what is 5x3. So you will know all these things. So please do check the link which I have dropped into the comment section, so that you can get a better understanding of the valve symbols, right? So the selection criteria and all those things are mentioned over here. So we will see these things in our upcoming videos. So this is something about the basic working principle of the solenoid valve, right? So let's check out now the valve operations in detail. So this is the direct operated solenoid valve. As we discussed, we can see the basic parts. The coil is there, then we can see the ferromagnet is there. The valve is now closed. When it gets energized, let's see what happens. The magnetic field, because of which the force is generated, and the spool gets lifted up and the valve gets open. Now again, when it's de-energized, the valve gets closed. So this is simple. This is direct operated solenoid valve. Now let's check out the indirect, or also called as pilot operated solenoid valve. Now we can see over here the pilot chamber. Now let's see how does it work. This is the pilot port. We can see now in the normal condition, we can see this is the closed condition. So let's check out what will happen. Wall is closed. Okay, now in normal condition you can see the upper chamber and the lower chamber over here. When the fluid is acting over here, the pressure is acting on the upper diaphragm and the lower diaphragm. Now the area on the top is more, so it is in closed condition. Now when the coil is energized, it gets open, and the pilot port gets open to atmosphere, because of which the upper pressure gets reduced and the valve gets lifted, right? So that's why we require a pressure differential. This is the meaning of pressure differential. You can see again, when it closes, the pressure on the top side is more, so it pushes the diaphragm on the downward side and it gets closed. So when the valve is open, the pilot port is like open to the system, and because of the pressure losses in the system, the pressure on the top side gets reduced as compared to the bottom side, and that's how it gets opened. So this is the pilot operated solenoid valve, and that's why we require a pressure differential for the operation of a solenoid valve. Now why basically we go for say solenoid valve? Because let's say if you require very high flow rates, then we have to go for a larger valve which will increase the size of the spool, the size of the coil, then again the current requirement will change, the power requirement of the valve will increase. So in order to avoid all those things, we can go for a pilot operated valve, that is a assisted kind of thing. We can see the pressure differential is assisting the valve for on and off, and that's why we can have a smaller coil over here along with larger flow rate. So this is one kind of advantage of pilot operated or indirect operated solenoid valve. So let's check out the semi direct operated solenoid valve. Now here we can see we have a diaphragm over here and a spring, and the diaphragm is connected to the spool. We can see over here the pressure is constant over here. Now as soon as the coil gets energized, the spool is lifted up and we have a pilot port. Now the pilot port gets open to the atmosphere, because of which the pressure differential is created. Now the pressure on the bottom side is higher as compared to the lower side, which lifts the solenoid valve. So here we can see that the valve is getting lifted because of some pressure difference, but it is not only because of the pressure differential, but we can see that the diaphragm is connected to the spool body, right? So this is the difference between say semi-direct and the pilot operated. In case of pilot operated, we might have observed that the diaphragm is totally different, it is not connected to the spool, so it is totally getting operated because of the pressure differential, right? So that's why for pilot operated valve, the pressure differential is must. Without a pressure differential, the pilot valve cannot operate. So we must have to verify that there is some kind of pressure differential across the valve. In case of semi-direct, if you could observe carefully, the diaphragm is connected to the spool only, so that's why it is called as semi-direct operated, right? So this is it about the working principle of the valves. We have covered the main basic types of the valves like direct operated, indirect or pilot operated, and semi-direct operated valves. So basically most widely used valves are direct operated and the pilot operated valves. So this is it for the today's session, guys, and if you have any doubts, please do write into the comment section below and we can discuss over there. Until then, keep intro making. Thank you for patient listening. Thank you.